Hello and welcome. This is John Lovell with the All Nation line. Today I'm going to continue my video series, Brass Investment Project, and discuss how I went about developing a kit for the Barber S2 70 or 100 ton freight truck. I find that sometimes doing video instructions is easier to follow than written instructions for modelers, which also gives a modeler opportunity to see where I make mistakes, maybe find better ways of doing the same thing to accomplish an assembled kit, and enjoy the project at the same time. So today I want to discuss producing a completed truck kit for some of my models, my waffle boxcar, and probably this is going to go under one of my brass tank cars that I'm developing from scratch and brass for my Chicago Great Western collection. So I want to show you first a completed truck before getting into the details of how we went about developing this. You'll note that when I spin these wheels, they're very free rolling, both sides. They got real springs and a bolster that can be drilled out to any size hole that you want, depending on how you're going to connect it. So what I did first off was get the FreeCAD program out and start sketching up the side frames, and these are what they look like. It's a roller bearing truck. They're flat on this side. We print them on the build plate flat, and what I wanted to do was, instead of just drilling journal holes and putting axles right into the journal holes, I had two options. I could use a brass bushing like this, but I decided I wanted to go with true roller bearings, and that's why these wheels turn so freely, and I think they're almost like being frictionless. So this particular truck has a 36-inch wheel. You can see a couple here. Some of my wheels I sometimes throw them in the little vibrator to shine them up a little bit or rough them up. This one's a little bit on the dirty side. It'll clean up really nicely. But I wanted to show you two different wheels, because for a freight truck you need one wheel that is insulated and has an insert like it's showing here. The other one, the axle can touch the wheel. It doesn't matter. We just don't want to short out between two rails. If you're a two-rail and you're still running DC in a two-rail power on board, you wouldn't have that kind of an issue. And what I've started out with is the standard All Nation axles. If you're ever familiar with their axles, they have the shoulder here for the wheel, and they have the end which goes into the journal. So what I like to do is to keep it simple, and I'm going to move us over to the drill press here shortly and demonstrate what I do to these axles in order to make the fit as a real nice snug fit. So I start with the standard All Nation axles, and if you're familiar with the parts of our All Nation trucks from the past especially, the axles had a shoulder here on the ends for the mounting of the wheels, and then the ends that go into the journals. Now, what I like to do is keep these projects simple. In other words, what I'm going to show you is we're going to turn these down a little bit, and we don't really need a lathe to do that. We can put them in a small drill press and chuck them up high to the chuck so that the ends aren't vibrating, and just with a very light file slowly bring these down. And what I generally like or prefer for my own modeling purposes is to make sure that I don't need a huge press to put these wheels on. A simple vise should suffice. And so if they're too tight, like this one here went right on, that was pretty nice actually, but they don't all go that easy. You need to apply some pressure a lot of times. And then the second piece of this is getting your insulator in the hole and pressing that on without pushing the insulator out. Now, in regards to the end of the axle going into the journal, we print basically a pilot hole so we know where our centers are. But if I were to use just a brass bushing, these bushings fit perfect on the end of the axle. You just drill this out a little bit and they would do just fine. But I'm not going to go with the brass bushing this time. I do like them, but I kind of like these ball bearings better, these little bearings that have a race. And of course, if you look, they're not going to go on the end of the axle very easy. So what I will do is show you how I go about turning these down ever so slightly so that I get a nice snug fit in the bearing, because you want a snug fit. You really don't want the axle turning in the bearing. You want the race to do all the work when the axle is turning. And finally, what we'll end up doing is showing you how to put these wheels together with some simple tools that I printed, so that I don't need a press, kick press, or some other high-end tool to mount wheels on axles, especially if there's a little resistance, and you do like to have some resistance there when you put them on. And what I generally do is I use a tool like this that I printed, that the axle will go in the center hole. It sits nice there in the plate. It's flush. Well, it's not completely flush. It is raised a little bit. And I will press the first wheel on, then come along, and I have a spacer block here that I'll put on the axle, because one of the things you want to do is make sure the face of your inside of your wheel is square to the axle. In other words, the axle's exactly perpendicular when it's in the hole. It's easy to get it twisted, and then the wheel would wobble down the rails if you don't get them perfectly square. So I'd come along with the second wheel, put it on, put that in, throw it in the vise, and squeeze it down. And when I'm all done, I'll have the right gauge. And normally what I do is I take my NMRA gauge and check my flanges, the width here from this flange to this flange. And the NMRA gauge is perfect for checking your work. And when you're all done, these come off. This pops out because it's really only a guide, and you'll have a perfect axle just like this already ready to go into your side frames. Before we turn the axle down, we're going to demonstrate first that we need to drill the side frames out. Now I've set the vise up here and also set the distance that I want to drill, because I don't want to drill all the way through. I only need to go to the distance for the thickness of the bearing. So we'll set this up here, drill two of them, and then we'll move on to turning the axle. Okay, so what I've done is I put the side frame in the vise, and you'll notice I have it flush across the surface, because once again I want to be able to drill the hole perpendicular to the side frame so the axle isn't leaning left, right, or up or down. We do want it to spin perfectly perpendicular to the side frame. Now I've already adjusted my drill bit for depth, and I'm going to let this run here, and hopefully this will turn out good. And again, you may have a better way of doing this, but I find this is good. I use a sharp drill bit and I take my time. This is ABS plastic, and it drills very nicely, unlike PLA, which tends to melt rather quickly, particularly if your drill bit tip gets a little warm. And so we find that the ABS plastic is strong. It has a little flex to it, and it's easy enough to work with, because once we try to put the bearing in here, we're going to have to take a little material off the side here, and I'll show you how we're going to do that momentarily so that the bearing fits snug in the journal. Okay, we're going to drill a second hole here in another side frame, and you will note that it is maybe a good idea to take a high intensity light. I use a little flashlight just to check that my bit is centering on the pilot hole. The bit I'm using is a 3/16, and it's almost the perfect size for these bearings that I have, and it only requires a little material to be removed after you drill the hole so that the bearing sits in the journal nice and snug. And there you have it. There was the other side frame that I did. I did both sides. I just have one more to do. I'll do that later. And now we're going to go on and talk about turning the axles down a little bit. Okay, so I'm using a standard All Nations axle, and what I'm going to do is chuck it way up in the chuck here, just like I would a drill bit, so that only a short portion sticks out. I'm going to give it a quick crank there, tighten it up, and the first thing I want to do is size down the end of the axle so that it'll fit in the bearing. Typically, what happens is you get these little bearings in your hand and they pop out and you lose them. They go on the floor and you can't even see them. So what I do is I keep it in the palm of my hand like this usually, and I'll check it like this to see if I need to take more material down. So that's how we're going to test it once we start taking some material off. Now, generally, what I use first is a fairly heavy file. I kind of like this one. You know, you kind of get used to your tools and you have favorites. And then I will go to a finer file and touch up the end. But really what I want to do is I finish with one of these little very fine files, and it allows me only to take a little bit off at a time as I get closer and closer. So what I'm going to do is we're going to go ahead and start taking some material off this, and it's going to work just like this. After you do a few of these, you really get the hang of it, and you start to find out that you can do them quicker, and there's less stopping and starting and checking. And we'll just check it real quick here, and it's starting to feel like it's fitting. So maybe we're getting a little close. And this is kind of the craftsmanship part of modeling that a lot of us like. And it's better than ready to run sometimes, because when you get done, you know you have a really well-crafted piece of workmanship. Now, one of the other things you can do when you're shaping the end of this is you can, instead of keeping your file perfectly flat against the surface, you can maybe tilt it this way, or if you need to cut a little bit more out of the corner, you can do it that way as well. In any case, you really do want to make it snug, and that's snug. So what that is ready to be put into the journal, the bearing, and when we get ready to assemble the truck, the axle and the wheel set into the side frames, the bearings will fit in your side frame, and your axle will go into your bearing with a nice snug fit, and they'll turn and roll really nicely. Now for wheel sets, I do the same thing. If I feel like these are too tight, this one happens to be very loose, and I did not touch this up ahead of time. There is some variance on some of the different wheels here. Now that one there is pretty snug, and almost most of the time you have to put these in a vise and crimp down on them, and that's what we're going to show you. How do we do that next? Now before we move over to the vise, just want to cover a couple of things. We have the two end caps that we'll use to squeeze the wheels onto the axles. Then I have the spacer that goes between the wheels, and I have two spacers. One is 1 millimeter wider than the other, and you will note that it is a good idea to take your NMRA gauge and start checking your wheel flanges. Now this one, I didn't make this wheel set, but whenever you get a model, it's not a bad idea to check the width of your flanges here. And this wheel set is squeezed a little too hard. The wheels are just slightly too close together, so if you have problems on your layout and you're running and you can't figure out why the heck it's derailing, that could be the reason. Now this here will not fit on this little extra wide spacer block, and that's again tells me that the wheels are too close together. And I'll use the spacer block that's a millimeter wider than this one, and pretty much get a perfect gauge on the wheels. There's one other thing to note. The wheel that does not have the insulator on it, the one with the smaller hole that would go on the axle, will bump up against the shoulder. So that's the wheel you want to mount first. The caveat with the wheel with the spacer for the insulator, which is usually just a piece of plastic, or in this case, this one here is fiber, you can press it a little too aggressively, and since it's a big hole, let me show you one with a big hole. Well, that's not a big hole. Where do I have one with a big hole? Without a spacer. Hold on a second. I think this one has a spacer, but what will happen is you'll press it and you'll go beyond the shoulder. And that's why on some wheel sets, that are designed this way, the wheels may be out of gauge where they're too close together. So the spacer does two things. It kind of prevents you from getting over aggressive and squeezing the wheels too close together. And the other thing it does is it'll keep your axle perpendicular to the inside face of your wheel. So when it goes down the track, it shouldn't wobble, right? It should turn with no sign of, if you just roll it and you look at it top down and see if there's any wiggle to it, you don't want that. So these simple little tools help prevent those kind of issues when you're assembling your trucks. Now we'll move over to the vise. So this is an old Craftsman 3.5-inch vise. The jaws on it are still pretty square. I use it for a lot of different little jobs in the shop. And this is to prove that you really don't need any heavy equipment to press wheels. Just some simple tools. And I should actually clean up my workbench here a little bit, but we get so busy with projects, things tend to get out of hand. But we'll take a day off and just clean the shop here and get it all in shape. First, what I do is I will put my first wheel that I want to squeeze right in the vise, like that. And what I'll do is I'll bring it and just easily, gently put this first wheel on the axle, and it could be really tight, and I would advise, if you're going to do this, to put these on. Always wear eye protection. You never know. Axle could snap, the plastic could crack and fly. Keep your eyes protected. So this is what we do. We put this one on here. I don't yet put the spacer in because there's not a need yet. It's just getting that first wheel on gets you set up. So then next, what you want to do is line up your next wheel, since you already got the one on there, and you're going to want to get this in the other pocket here and open up your vise. And what we're going to want to do is try to center it and keep pressure this way so the base of this is flat on the face of the vise, and then you can bring the jaws together and start making sure that it feels right and it looks right, because you kind of want to watch here that you're not going to press it and cause the wheel to angle or bend the axle. We put our spacer in there, and all we do is crank it up and bring that wheel all the way forward. And that's as simple as it gets. And most of the time your results are perfect, and when you're done, you want to take it out of your vise and immediately check your gauge. If you happen to have squeezed them too hard, then it can be a little tricky to back it off. But the wheel you want to back off is not the first wheel you mounted. The wheel you want to back off is the one with the insulator, because it's going to slide easier and it'll be easier to adjust. So that's the end of this video. I hope you enjoyed it, and give me some feedback if you will. And I'm certain that you'll enjoy building your own trucks. Now, the next segment here, we're going to show you how to put the springs in the side frames and have a complete wheel set, completed truck. So what we do is we use the number 1544 truck springs. That's the part number, the All Nations part number for our trucks. And we use those springs in the Andrews, Bettendorfs, and any other truck that they seem to work well. They tend to kind of come together, and you got to unwind them, but they're very easy. And what we typically do on these is we'll go ahead and take the bolster, put it in there, and bring it up like so. And there's little nubs on here, and we want to adjust it so that the side frame is, the bolster is perpendicular to the side frame. And all you do is set the spring on the first nub and pop it in, and you do that 3 springs on each side, and you'll have a finished truck just like this. And those springs hold that bolster pretty tight. You don't really need any other mounting. Now on the printed stuff, a lot of times I'll take a light file and I'll clean up some of the threads on it so that it looks good. But you should have a very nice truck that rolls down the track with these bearings in the journals, and I think you'll really like those. And that's the end of this video. We hope you enjoyed it, and give us your feedback if you will, and we'll be coming out with these trucks very soon.